Okay, so the dot product. So you actually have to put a literal dot. So u dot v, that's how you say it, is u transpose v. So you take the transpose, so they're both column vectors. So if we take these column vectors and write this column vector as a side row vector times this. So what we do is just like we multiply u1 times v1, that gives us a number. u2 times v2, that gives us a number, all the way down to un times vn, that gives us a number. And so this dot product gives us a number. Okay, so a dot product gives you a number. So u dot v is the same as v dot u. If I add two vectors and dot it with the w, I can think of that as distributing the u dot the w plus the v dot the w. If I have a constant times a vector and then dotted with the v, I can take that constant on the outside, right, and then do the dot product because that's a number. Or I can take that constant and move it to the v and then do the dot product, because you can move our numbers around in multiplication. If I take if I dot a vector with itself, because of the nature of multiplying and adding, right? It's always multiplying and adding. All negatives will be gone, and so this will give you a positive number. It will only equal 0, right? U dot u will equal 0, dotting it with itself, not another vector, but with itself, only if the vector itself is 0, the 0 vector. The length or norm of a vector is taking the dot product with itself and taking the square root of it. So to take the length of a vector v1, I take the first component, square it, take the second component, square it, all the components, and add all those squares together. That will give me a number, and that's the length of the vector. And so a lot of times we like to see the norm squared is v dot v, and then go find out what the length is by taking the square root of that. If I'm finding the length of c times a vector, I can just literally take the number, the absolute value of that number, c rather, outside and find the length of the vector. A unit vector, just the word unit means 1. It's a vector of length 1. A unit vector is a length 1. So to normalize a vector, that's the process of making a vector of length 1 called u that's in the same direction as v. So if I've got this vector v here that's huge, it's not of length 1, I'm going to find u, which will be of length 1, that's in the same direction as v, right? It would be just part of it, let's say. So the unit vector u would be in the same direction as v, and how I find that vector u, and let's just say this vector v has length 5. So the u would be 1/5 times the vector v, and that's what this would be. So it's 1 over the length, which is a number, times the vector v. It's a fact that the word orthogonal means perpendicular, so two vectors are orthogonal to each other if their dot product is 0. Right? Dot product is 0. Remember, the dot product was 0 here only if you were doing it with itself. So here I have two different vectors. Their dot product is 0. If their dot product is 0, then they are orthogonal. All right, so let's just do a little bit of arithmetic here. So let's do u dot u. So u dot u, so that would be writing this first vector, a transpose, so as a row. So -1, 2. Oops, sorry, it's kind of messy. All right, so then let's multiply -1 times -1, +1, and then +2 squared, right? So that's 4 plus 1, so that's the number 5. So u dot u is 5. All right, so let's do 2 times v dotted with u. 2 times v dotted with u. So let's do the 2 times the v, so that would give me 8, 12. Dotted with the u, so that's -1, 2. So this gives me -8 plus 24. So that's the same thing as 16, right? All right, so let's do this one. The norm or the length of the vector v. So the length of the vector v will be the square root of each of the components of v squared. So 4 squared, 6 squared, so 16 plus 36, so what is that, 52? So square root of 52 is the length of v. So this is asking us to normalize v. So again, let's get a picture going here. So this would be the length, or this would be the vector v, which is not of length 1. Actually, I know what the length is, right? So this vector here has length root 52, because I just figured it out, right? The length of this vector is root 52. So to normalize means to find the vector of length 1 in the same direction as v. So it'd be me finding this little vector here, right? So that would be 1 over the root 52 times my vector v, right? I'm just going slow. You don't have to go this slow. So times the vector v, 4, 6. And that's fine to leave it like that. Or you might want to write it like this, right? 6 over root 52. Okay. So if asked if two vectors are orthogonal, you check to see if their dot product is 0. So I'm just going to write it out. So negative 16 plus 15, that equals negative 1. So since it's not 0, they are not orthogonal. All right, so if I'm trying to find the distance between two vectors, it's described as it is defined as the length between the length of the vector u minus v. So first find u minus v, then take the length of it. So if I'm trying to find the distance between x and y, I first want to find the vector x minus y. I'm just going to go slow so I don't make any mistakes. I'm sure I still will, but let's try not to. So 10 plus 1 is 11, negative 3 plus 5 is 2, so that's my vector x minus y. So then what I want to do is I want to find the length of this vector x minus y. So the length of that vector will be, so I'm just going to call it z for a second. So the length of that vector z will be the square root of 11 squared plus 2 squared. So that's 121 plus 4. So the square root of 125. Well, let me stop it there.